Assalamualaikum warahmatullahi wabarakatuh. Praise and gratitude to the Almighty God who has given us health and opportunity, which despite the coronavirus outbreak, we can still attend the seminar activities in online. Thank you very much for the opportunity given to me. My name is Jacob Likwatil from STT Mandala, Bandung. Will represent the other team to present our journal paper entitled Electrical Energy Alternative of Magnetic Field Around Wire of Pole Line. The background: electric energy crisis and consumer need. Consumers are increasing while the availability of electricity is decreasing. Second, the existence of electric lines with alternating electric current generate a large magnetic field around and along the power line that store electrical energy, but that has not been utilized. Three, there are public concerns about the danger of electromagnetic field radiation near the location of the power line. Purpose of this journal: research utilizing the magnetic field that is on the primary power line and making it a new source of electrical energy. Second, making an equipment that can take the magnetic field flux into an alternative magnetic power based field with a voltage of 220 volts to provide electricity to the community near the location. Great. Change people's image about the danger of electromagnetic field radiation. The basic theory: the understanding in the electromagnetic field technology on electric power line is based on Maxwell law, Faraday law, and several other laws. This fix an illustration by Maxwell law. If current flow in wire will generate magnetic field along the wire with a magnetic field encircling the wire. In this fix, conductor rod, it will be generated by magnetic field around the generator with circular pattern, and the direction of motion of the magnetic flux is to follow the rules of the right hand flaming. And next, and how to take away the magnetic field energy on the power line. We used a toroid. This toroid in fix 3. A toroid is equipment that functions like a transformer. Magnetic weight and intensity of aids can be collected by the toroid core. However, with the primary and secondary coil placed in a number of zones of copper wire, this coil is used as a secondary winding N2, which is connected to the load. and the electric power line wire is passed into the toroid cavity as a primary coil and one which flow primary current I1. The physical size of this toroid will determine how much magnetic energy can be taken. The greater the diameter and thickness of the toroid, the more magnetic energy will be taken. The large toroid size, especially the thickness and diameter, will be able to take more magnetic flux from the magnetic field. To supply the load condenser lamp or electronic lamp with power P2 as the nameplate of the lamp with a voltage of 220 volts. Required primary current on power line that is equal to I1. This I1 is current flowing power line. In another sense, that the current of the power line will be able to generate power at the load by P2 asterisk at a voltage of 220 volts. This voltage, the occurrence on loads, the value of the voltage that can in the load mounting P2 asterisk in what? In the secondary side of the toroids is V2 is dependence of current flow in power line I1 and K is the constant of the toroid deviation factor due to the nature of toroid saturation. Next, and to get the data, we conduct a simulation experiment in the laboratory in two ways as follow. In fix 3A and fix 3B. In fix 3A is experiment 1. The system used an induction motor as a load of electric power line to obtain a large current flowing in the primary power line because a small electric current cannot produce enough magnetic field energy to light the lamp normally. And fix 3B is experiment 2 using an alternating pole regulator and a step-down transformer to obtain a large and varied current on the toroid primary side and to find out how much current must flow on the power line so that energy magnetic field can produce a normal voltage of 220 volts at the load on the toroid secondary side. And this result of the experiment as shown in table 1A, we can see incandescent lamp 5 watt, current flowing in power line 27 amperes. For lamp 5 watt, voltage occur on the lamp to 160 volts. Description: dim. An incandescent lamp of 10 watt of 60 volts, very dim. Electronic 7 watt 200 volts. The description is bright. From the result of the experiment with a low current of 27 amperes on the power lines as shown in table 1a, the state of the incandescent lamp is 5 watt. It is light up but is dim at 160 volt, and 10 watt incandescent lamp also light button with a voltage of 60 volt. This is caused by the wave intensity of the magnetic field near generated by the electric power line current, while the 200 volts. The second experiment in table 1b. In table 1b, we can see that from the result experiment with a medium current of 80 amperes on the power line, as shown, we can see for the 10 watts incandescent lamp, it's bright lit at voltage greater than 220 volts. And for a 60 watts lamp, it light up but is dim with a voltage of 165 volts. This is caused by wave intensity of the magnetic field generated by the electric power line current. But for 15 watts electronic lamp cannot detect the voltage value because the lamp suddenly explodes and goes out. And next, an experiment 2. How much current will be taken for the light, for the lamp for 40 watts is 70 amperes, and 60 watt it's 105 amperes, and 100 watt current 175 amperes, and electronic lamp 7 watt. The current in the power line is 30 amperes. The value of the current in the table 2 above is the left excitation current is required to flow on the wire of electricity to power the light button toroid size or type at the price of normally voltage of 220 volt. Next, this is characteristic of the experiment, the result of experiment in the table above, and see for 100 watt incandescent lamp with red color, for 60 watt blue color, and 40 watt black color. Next, conclusion. First, the magnetic field energy along the electric pole line can be utilized as alternative electrical energy using toroid. From the analysis through the linear approach that in power lines with large current up to hundreds of amperes can be obtained power up to several kilowatts at 220 volt. The greater the electric current that flow in the power line, the greater the magnetic field energy around the power line. Second, the more toroid is installed along the power line, the more new electrical energy will be obtained. And then is the simulation circuit. We make use several of the toroid sites. Site T1 is a site on the peak, and this T2 is middle, and small T3. And finally, thus the paper that I can convey is sincerely Alkokin, Jakob Liklik Wakil, Sabrudin Gifir Retira Ramjani Lestari Herawati YS Rahmat Hidayat Sekolah Tinggi Teknologi Mandala Bandung Universitas Kristen Bandung. Assalamualaikum warahmatullahi wabarakatuh. Peace to all of you. Thank you very much.